Hi, class. In this video, we're going to answer the question, how do you find the area of a sector of a circle? How do you find the area of a sector of a circle? And then we'll go beyond that. You may be able to recall, I think we've already gone over this, how do you find the area of a sector? But on top of that, we're going to take a little twist with what we know of finding the area of the sector and also look at finding other unknowns in that type of relationship. Maybe we have the area of the sector um, and we want to, and maybe the measure of the arc or something, and we want to find the area of the circle. Okay, different relationships dealing with the sector. So remember how a sector of a circle is defined. A sector of a circle is a region that is formed or bounded by two radii of the circle, and then bounded by the arc that these radii form when they intercept the circle. Okay, so here we see an example of a sector. We name a sector by the central angle that forms the sector. So this would be called sector CAB. Okay, and in this relationship here we have the measure of angle CAB, which is 81 degrees, and we also have the length of the radius. And with that, we should be able to determine the area of the sector. Okay, and again, you may understand that. I'm just going to assume that you don't, and then also various forms of this relationship. So I'm going to start with the beginning. If we're going to find the area of the sector, we first need to be able to find the area of the entire circle. So let's just review something that you learned probably in elementary school, elementary or middle school. How do we find the area of the circle? Some students and people get the area of the circle and the circumference of the circle mixed up, where the circumference of the circle is 2 pi r or diameter pi. The area of the circle formula is given as pi times the radius squared. So we take the length of the radius, square it, multiply it times an estimated value of pi, and that gives us the area of the circle. Okay, so let's just practice that real quick. Here we have the area of the circle with a radius of 4.2. All right, so how can we find the area of this circle with a radius of 4.2? Well, we'll just use our formula. Plug in the value of the radius. And remember, it's squared, so we're going to square 4.2, which is 17.64, times an approximated value of pi, which is around 55.42. Okay, and that value is probably greater than more precise than 3.14. If you use a calculator key, it may go out to like maybe 3.1459 or something like that. So somewhere around 55.42 you should get if you're practicing along or you're trying this along with me with a calculator in hand. So what about in this case? Now notice this, in this case we have the area of the circle and we want the diameter. I wonder if you know how to find that. How do you find the diameter? Well, what we can do is we can start with what we know. We know the area of the circle, pi r squared. And so let's take our formula and plug in what we do know. We know the area is 201 square inches. So that's equal to pi r squared. Okay, so now all we need to do is use some algebra and solve for the radius. So we can divide both sides by pi, as the step says here. Okay, so that would leave us with 201 divided by pi. That's equal to the radius squared. All right, and we don't want the radius squared. We want the radius. Okay, so remember, a square root reverses something that's been squared, so we'll take the square root of r squared to get r, and then what we do to one side, we have to do the other. So the square root of 201 divided by pi, I'll try this in your calculator, make sure you can use your calculator keys properly. Because again, order of operations and such, just make sure that you can take the square root of 201 divided by pi and get approximately 8 inches when you round to the nearest inch. Okay, now are we done? No, we're not done. Pay attention to what the question is. The question is what is the diameter? We've solved for the radius, so we have to do what? What do we have to do to the radius to get the diameter? That's right, we have to double it. So if we double 8, we get 16. So the diameter of that circle is 16 inches. Okay? Now let's move on to what we started with. How do you find the area of a sector? So I'm going to give you two formulas, and either one of these works. They're basically the same thing. One's in proportion form, and then one's in a basic algebraic equation form. So the ratio of the area of a sector of a circle to the area of the whole circle is equal to the ratio of the measure of the intercepted arc to 360. Okay? So the area of the sector over the area of the whole circle, which is pi r squared, is equal to the measure of the arc over 360. Now what is this ratio giving you? The measure of the arc over 360, what is that giving you? It's giving you the fraction of the circle. Okay? Remember when we looked here, and I said, how do you find the area of the sector? We have a central angle of 81 degrees. So the fraction of the circle is 81 out of 360, and that's that ratio that we're just looking at. Okay, so let's just say this is 1/5. If it was 1/5 of the circle, then I would take 1/5 times the area of the circle, and that would give me the area of the sector. Okay, that's what we see here. This right here, area pi r squared, radius times pi, gives me the area of the circle, and then I multiply that times the fraction of the circle that the sector is, and that will give me the area of the circle. The area of the sector is a fraction of the entire area of the circle. Okay, so that's the relationship we're seeing here of the area of the sector to the area of the whole circle equal to the measure of the arc over the whole angle measurement of a circle. That's the fraction of the circle. Okay, so we could also look at that, like we just said, as the fraction of the circle. This is the fraction of the circle, the measure of the arc. Remember the measure of the arc. This is the arc in this example, the measure of the arc. Let's say this is 80 degrees. The central angle is 80 degrees. Remember the measure of the arc is also 80 degrees. Okay, so also to find the area of the sector, we can find the measure of the arc over 360 times pi r squared times the area. Okay, so you may want to write one of these down, one of these forms down on your homework when you're doing your homework to refer back to. You may or may not. It's fine when we're going straight forward looking for the area of the sector. But what if we're given the area of the sector and we're looking for the area of the circle or the measure of the arc? Okay, that's when it helps to do a proportion or an equation. What I tell some students is, because this works for some students, it kind of simplifies things as far as remembering an equation or a proportion or the relationship. You just say part over whole is equal to part over whole. Part over whole in angle degrees, angle measurements, part over whole in area. Okay, this is just like arc length. We looked at part over whole in angle in degrees over part over whole in circumference. Okay, so when we're dealing with the area of the sector, the whole in degrees is always going to be 360 degrees. Okay, 360 degrees, because that's the whole angle measurement of a circle. The part in degrees, that's supposed to be a degree symbol. The part in degrees is the angle measurement that forms the area of the sector. Okay, the central angle. That's the part of the 360, and it's the part that forms the sector. So in this case, we're dealing with a central angle that forms a sector, and it's 81. So we've got 81 over 360. Then you have the part of the area over the whole area. Now neither one of those is given directly, but we do have the radius, so we could just say pi times 4.45 squared. That's supposed to be a 4.45. Okay? So part over whole, that might help you remember. Part over whole, because this works for arc length and area of a sector. Part over whole in degrees, part over whole in area or circumference, depending on whether or not we're doing arc length or area of a sector. Okay, so that's something else that you might want to write down in your notes. Now let's work at applying this. Let's start with just finding, pretty straightforward one. Find the area of the sectors formed by angle RQS. Okay, so here we have the measure of the central angle, which is also the measure of the arc. We know the measure of the arc is 63 degrees. Okay, and so find the measure of the minor and the major arcs, because find the areas of the sectors formed by angle RQS. Notice it says sectors plural, so it looks like we want both of these. So the measure of angle RQS is 63 degrees, so that's the measure of the arc. Now what about the measure of arc RPS? Right, that's 360 minus 63, which is 297. Okay, so how could we do this? What would be your plan? Okay, if we can find, we have enough information to get the area of the smaller sector, and then with that, we could just take from it the area of the entire circle, and that would give us the remaining area of this large sector, correct? So the note-taking guide is using the formula, the area of the sector is equal to the measure of the arc over 360 times the area of the circle. So for the small sector, we got 63 over 360 times area square, pi r squared, the radius is 5. So we find that the area of that smaller sector is 13.74. Okay, so we could do two things. We could get the area of the large, or the whole circle, pi r squared right here, and subtract 13.74 from it, or we can go directly continuing to use our formula. And remember, we said the measure of the major arc is 297 degrees. So 297, and in your calculator you could do something like 297 divided by 360 times pi times 5 squared, or you could do 297 times pi times 25, 5 squared divided by 360. Okay, best thing to do is 297 divided by 360. So we have 64.8 is the area of the large sector. Okay, so the area of the small and large sectors are about 13.74 square units and 64.8 square units. Now I've got hidden behind here a slightly different way using part over whole and then subtracting. All right, so like I mentioned earlier, subtracting. So part over whole, the part of looking for the small sector, the part of the 360 that makes up the area of the sector, 63 degrees over the whole angle measurement of a circle is equal to the part of the area over the entire area. And with a proportion, I could just simply do 63 times pi times 5 squared, or times 25, divided by 360. Remember the pattern for solving a proportion with one unknown: multiply the diagonal with the number in both spots, divide by the other. Okay, so then I could just, again, an alternative method, finding the area of the larger sector, I could get the area of the circle and subtract from it the area of the smaller sector, and what's left gives me the area of the larger sector. Okay? So, what's next? Now we have a little bit of a indirect, we're given the area of the sector, okay, and we're asked to find the area of circle C. So I think I'm going to stop the video here and start a new one for this example and the remaining example. So let me stop this.